This is a video on techniques using Excel. It's part of the continuing series of videos on Excel and VBA best practices with a focus on manipulating and accessing external data. This video is brought to you by PolarisInvesting.com, a site for creating defensible valuations. Recall, business valuation is based on expectations derived from skillful consideration of past facts and future possibilities. Recall that the videos in this series are broken up into Excel-based videos and then back-end VBA-based videos. This is the last in the part of the series that's on Excel. We're talking about techniques that are useful in manipulating and accessing data. First topic I want to talk about here is dealing with date and time. And when you're dealing with date and time, typically being an Excel user, you're just dealing with the Excel date time, which most people realize is stored is what Excel calls a serial number. And the serial number is a decimal number consisting of an integer portion, which is the date, and the fractional portion, which is the fraction of a 24-hour day. And the fraction is granular as seconds. Date is assumed to start from January 1st, 1900. So it's the number of, the integer portion is the number of days from January 1st, 1900. And then the fractional portion is the fraction of a 24-hour day in granularity of seconds. So in working with that kind of date time, and you want to know just the date, you just do a truncate of the now function, or you can do an integer of now. Now, we did talk about integer in a previous video and some issues with negative numbers and rounding issues, but we're always dealing with positive numbers here when you're dealing with dates, so there's no issue with whether you truncate or use the int function. You are going to end up with just the date portion. Now, if you want to get the time, which is the fractional piece, then you just go get the date time, subtract off the integer portion, and what you're left with is the fractional portion. You can also use this mod function. To manipulate the serial number, main function is the date function, and it consists of three parameters: the year, the month, and the day. This example shows that you're using a function called year to go get a year of a serial number contained in cell A1, and then you're deciding to subtract off so many years, or you can add or do some kind of arithmetic operation to that parameter. Then you do use the month function to get the month of the serial number that's in cell A1, and then do some mathematical operation on it, and then use the day function. And then when you run it, those three parameters inside the date function returns back a new date. So it's a way to manipulate an existing date by using the year, month, day inside the date function. Now, you can also, if you're just dealing with date, you can use a function called edate, and it comes from the dealing with bonds, or that's the real purpose of this function, and it stands for effective date. But again, that name comes from dealing with bonds, and again, you input the serial number in some cell, and then some -1 or add 1, how many ever months you want to move around the current date. Another date-related function you should be aware of is called date value, and there you can convert a text string into a serial number. Now, when you're dealing with pulling data from all kinds of data sources, there's nothing that says that the a value that you're pulling that represents a date has to be in the form of an Excel or really Windows date time. Most often when you're pulling a date, it'll be in text form, and then you just simply run the date value against it to get it into Excel serial number. But occasionally you'll come across a data source where they've, for date, they'll either just use the Excel or Windows serial number, or sometimes you'll end up with a data source that time is based on Unix date time. Well, Unix date time starts in January 1st of 1970, and its granularity is in milliseconds. There is no fractional component. It's just simply all integer, and it's the number of milliseconds. So if you get a Unix number, you've got to convert it into an Excel serial number. And here's the algorithm to do it. You use the date function that we already talked about. You can see here year, month, day. You then divide by 1,000 because the Unix time is dealing with milliseconds, and then you divide again by 86,400 because that's the number of milliseconds in a day, and then that converts it to an Excel serial number. Next, we talk about dealing with blanks and non-blanks and how to determine first and last row in a column containing a non-blank. After that, we will be talking about essentially how to remove blanks or create a column from another column that has all the blanks removed. All right, to take a look at this, we're going to use the page 2 of the filter test spreadsheet, namely this area in here. And going to deal with this column in here that has some sample data in it, and then look at different functions provided by Excel and see what how we can use them to deal with blanks. Well, first off, let's talk about how do you determine the number of blank cells in a column. So here's the formula we're talking about that Excel provides called count blank. It does require a very explicit range. You can't just say from like end to end, which would be the entire column. But you have to specify a specific range. So if we say from 1 to 10, and we ask it to count the number of blanks, you can see here that the actual formula itself is in this column. It comes back with 4, and yes, that's correct. So that's a good function. So if all you're wanting to do is count the number of blank cells in a column, recommend using that formula. And anything that's recommended is got a background of light blue. All right, well, now let's talk about determining the number of non-blank cells. So a formula that would seem reasonable to use is called count A. Microsoft documents that count A will count the number of non-blank cells. But if we execute that function, we get the number 7. But we know that based on the previous calculation of how many cells, at least in this portion of the column, was blank, that we should only be counting 6 as non-blank, and 6 that you see in column M. But you can see here it's saying 7 are non-blank. Well, the reason is because here in this cell here we have a formula. It just simply is blank, but it is a formula. So this count A function really counts occupied cells, and if it's occupied with a formula, then it counts as being occupied. So for the purposes that we want it to serve, it just produces the wrong number. Now the way you can correct it is to count A and then subtract off any cell that has a formula in it that's also blank, and then that gives you the correct value. That's a little clunky. A better way to do it is to use this method here, where you use the count function. Again, that's not count blank or count A. There's another function in Excel called count, and count will count the number of cells that contain numbers or numeric values. Count if is now used with the wildcard as shown. to give you the number of cells that contain text that aren't numbers. Now it's important that you used not just the asterisk, but the as shown, the question mark and asterisk. And that gives you the correct number, and that's the recommended way to count the number of non-blanks in a column. Okay, next we're going to talk about how to determine the first row containing a non-blank and also the last row containing a non-blank. So you see up here the formula that's recommended for determining the first row containing a non-blank is a little bit tricky, and down here we have the text that talks about the tricky part, which is used inside of the match is an index, called an index function with one of its parameters is 0, and that 0 parameter results in the index function returning back an array. And with that, I'm not going to go through the whole explanation of how that works. Leave it up to you to spend some time with it, and if you desire to try to really understand how it's working. But the main thing is it works, and recommended way of determining the first non-blank in a column. Another way you could do it is a little more straightforward, but it uses an array. An array is essentially causes Excel to loop through every cell, and that's just not real efficient. So you should always try to avoid using arrays if possible. And since there is another way to do it, not using arrays, this is not a recommended way of determining the first row containing a non-blank in a column. All right, let's turn our attention now to determining the last row containing a non-blank. Well, there's a tricky way to do it, and right below there's a more straightforward way, and I want to talk about it first, where it's essentially the equivalent to the more tricky way, except that it uses explicitly the unary operator that converts this array of true-false to 1, 0, and then it's inside the sum product will take the row number, so it ends up with and then the max, it'll end up with the row number that is occupied, and that's how that works. Now the more tricky way is equivalent, but it's not as obvious there's a unary, implicit unary conversion going on, because there's arithmetic involved, multiplication here. Excel automatically converts true-false to 1, 0. And that's why that works, and it's equivalent to this other one. Now another way is to use arrays, and that's shown in here, and we already talked about the inefficiency of using arrays, so it's not recommended. Another way is to use an old now deprecated by Microsoft function called lookup, preceded HLOOKUP and VLOOKUP and soon to be XLOOKUP. But it also has another downside, is that it requires at least one cell in your column be occupied, and if not, you'll get an error. So for those two reasons, deprecated function and requiring at least one cell to be occupied, it's not the preferred way to go. And then another approach that is recommended is a Polaris provided function called last row in column. And this is just a way to be very explicit. You indicate the worksheet, exact column in the worksheet, and the range that you want to determine the last occupied row. All right, next we're going to talk about removing blanks. And another way to think about it is let's look at this back on the filter test, column A here. Got a list of salespeople, and you can see here that got intermixed. We got some salespeople are listed more than once. We got some blanks. So another way to think about this is it's kind of you're condensing or burping a sparsely populated column. The way you do that is by using this formula here. So we'll see here that is implemented in column C. The formula is actually pretty straightforward. It's just uses this small function, and along with so just defaulting to the smallest is now, as you fill the column, this goes from C2, C3, C4, so it gives you numbers 1, 2, 3, 4. So you start off with the smallest, the second smallest, the third smallest, the fourth smallest, and get returns back the row location, and then you index use the index function, and then there's where you get the values that appear down this column. The method we just went through ends up with a new column being created, and the original column stays in the spreadsheet as it was. Another approach you can do is highlight the area that you're interested in removing the blanks, and just hit Control G. It brings up this Go To pop-up, select Special Blanks, and now it'll flag all the blanks in the area that you highlighted. And you come up here on the Home menu and select Delete. You can either delete the entire rows that those blank values reside in, or you can select Delete Cells, which means you're just dealing with the column itself, and then you can choose what to do with the delete in terms of the remaining cells, if you want to shift them up or whatever. So here I can do Shift Up, and you can see here now all the blank values that I had are now gone from that column. Another approach is to highlight the area you're interested in removing the blank values from, and go to the data menu and just simply do a sort, and take the default sort order A to Z, and it'll put all the blank values at the end, and there you've removed all the blanks. Well, next we're going to talk about how you go from just removing blanks to now getting the distinct values out of a column, and then we'll also talk about moving even beyond that and alphabetizing those distinct values. So here in column E is where we're determining the distinct values. First off, we're going to talk about how to get just the number of distinct values. Here we're referencing column A, and you can see the formula here that ends up, it's a rather ingenious formula in the way it uses COUNTIF and uses division, and I'd encourage you to spend some time with this and see how this works, but it's a pretty ingenious way to come up with out of the original data, how to come up with the number of distinct values in one function call like that. All right, next I want to talk about how you can identify the first distinct value out of the original set of cells, including that includes blanks. It uses this function here, which kind of the main part of it is the fact that it limits its COUNTIF range always to be equal to what came before it. So here we are in row 2, so it just says COUNTIF if this next thing you're looking for has already appeared in the distinct value list here in column E, then don't use it. So when we first get started, there is no 6 in the original data source. So when it goes back and sees if it's found AND before, it hasn't. So AND shows up. When we go to the next cell, now we're looking at E1 and E2. So now AND is no longer not found. It's now on the list. So now when we count, it'll show up if we find it again over here in column A. So you're looking for a match of 0. When do we have a value over here that doesn't appear previously? And then this formula will find that row and index it and then show the value. So we just keep doing that down through all the different values, and you can see here as we get pretty far along, we're now looking back from E1 to E6 in the current distinct value column. Well, now they got a column with the distinct values here in column E. Now I want to alphabetize those, and the way you do that is by using the countF function, countIf, and you can see here that it ranges from row 2 in column E through row 7, because it just looks at the total number of entries in column E, which is in the number 6 there in E1, and this adds 1 to it because we start in row 2. And then it says less than E2. So it wants to know how many values in this list is considered to be less than AND. Now what complicates this a little is the countIf function. Ranks text and numbers separately. So as it does this evaluation less than AND, it'll, since AND is text, it'll only rank it as it goes down comparing to the other items in the column, only to other text strings. And then if you were to end up if one of these values in E was a number, let's say down here this was 7, when it hit that, it would then rank that compared to other numbers in the column. So what you do is you count the number of numeric values in your list, and then as you go through and count, you say, well, is this value I'm currently comparing everything else to, is it text? Well, if it is text, then you want to add to it the number of numeric values are in your list as well. In other words, you're putting the text rankings after your numeric rankings. So numbers will appear first in the when you alphabetize, and then the text. But you can see here we don't have any numbers in our list. So this is 0. So when it does this calculation, you can see here that there is no other members of the list that are alphabetically considered less than AND. But since we're starting in row 2, what this does is it adds 2 to that return value of 0. So we end up with a 2. Then here, John, there's actually 5 other values considered to be less than John. Add 2, you get 7, and then so on through the list. And then when you move over to column H, this is simply doing an index of everything in E, and now it's matching the row that you're currently in. Here in column H, it's just using what row the cell's currently part of. So this is row 2, row 3, row 4, row 5, row 6, row 7. So going back here, 2, it says what's placed out of this list, what came up with the second ranking. Because again, we're adding 2, remember right here, so because we're displacing by 2. So we're using 2, and it says, all right, that's what I'm looking for. Well, that's AND. So AND gets placed here. Now this is row 3, which had 3. John. So John gets placed here. Which had 4. That was Mary. So Mary gets placed. 5. That was Susan. 6 is Tim. 7 is Tom. And therefore you have an alphabetized list. Well, a quick review of what we've done to get to this alphabetized list in column H is we started out with this list here that it had some blanks and redundant entries, so we had to remove the blanks in this column, and then we went here to get rid of any redundant entries, so now we have distinct, and then we alphabetized. So it was a 3-step process to end up with non-blank, distinct, and alphabetized values from this column A. So it makes you wonder if there's not maybe a simpler way to do that. Well, it turns out that there are 2 other ways that simplify the process. One is something that Excel provides, and if you go to the data menu, there's this advanced filtering. Well, not only can you use it just from an interactive standpoint, but it's also available programmatically as VB code. And we'll be talking more about that VB code of the advanced filter in the very next topic dealing with data aggregation, so I'm not going to go through it here. The way I've got it set up here in this spreadsheet is if you just clear this cell, column K will automatically take whatever starting in row 6 of column A and produce non-blank, distinct, alphabetized list. I'm looking at the VBA code. When you clear J1, what it'll do is it'll call this function called DistinctSort, and it's here, but you can see here that it's actually calling the advanced filter and then eventually calls sorted, and things we'll be going over in the very next topic. But if I come out here now and clear this entire column and now run the advanced search, you can see it very quickly creates an alphabetized list. Well, another way, and actually the preferred way to create this alphabetized list, is to call a Polaris provided function called DistinctSort. The quick look at the VBA code for that is shown here, DistinctSort, and this function actually, and it calls another function called SelectSort down here. But these two functions were actually taken from Paul Kelly. I referenced his VBA programming videos in the introductory video of this series. Using it makes it extremely easy. Now I went ahead and just counted the number of distinct values. You just simply, and you can see here there is no other, it returns an array, so there's only one formula, a cell with a formula in it, and you execute it and it's pointed to here that this is the items that we're wanting to alphabetize, and also get rid of the blanks and any kind of any redundant values. And it's a very quick, efficient way that eliminates having to set up the advanced filter, eliminates doing all the intermediary steps here in your Excel spreadsheet. It's just one simple call, point it to the source list, and you got it. So very, very efficient. And next here we're going to talk about aggregating data, or kind of rolling the data up into some kind of a summary view. And here on the filter, the page 1 of the filter test, we actually went over this section at the end of the previous video on Excel functions. So I'm not going to spend a lot of time on this. Just a reminder that this showed that by using the SumProduct function along with the unary operator, we could be pretty specific as to criteria that we want met in order to roll up. So by using the DistinctSort, we can quickly get a distinct list of alphabetized entries from this column, and then by using the SumProduct, we can quickly get summary data from the base data. Well, this is actually one of the preferred methods to do aggregation or roll-up data. The other preferred way is by using pivot tables, and we got two examples of pivot tables over here. I'm going to go ahead and delete these and then recreate them during this video. But first I want to talk about what's going on over here with the advanced filter capability of Excel. Advanced filter doesn't really aggregate data or roll it up, but it does allow you to, as the name implies, filter this data or these records here based on criteria, and therefore it is a tool that you should add to your toolbox. It can be useful for certain situations. So I do want to briefly cover it for that reason. One way you can run advanced filters is just here from the menu. If you go over here to data and do advanced filter, this pop-up comes up and it says, okay, well, what is where's the original data that you want to filter? Well, since I had it highlighted before I called it, it defaulted to that. Then it's going to ask for where's the location of the criteria that you want to use, and then I can specify whether I want to copy right in place, but I don't want to copy to a new location. and then it's already correctly identified where I want to put it. Now, where I want to put it, I also got to indicate what fields am I interested in, and so it assumes that the first row where I want to put the data does have the fields that I'm interested in. And then I also could click unique records. Now, in the context of what I'm doing right now, that doesn't make sense, but we will see later on and how to use this feature to get distinct values. Let's start over and go through the whole process. I'm going to clear out the results set, but I am going to indicate in row 1 where the results set's going to go, what fields I'm interested in. Criteria has what criteria I'm interested in, what fields in the first row, and then the actual values of the criteria. Then here's the actual data that I want to filter. So real quickly, I go up here to Advanced. Since I've run it before, it knows the criteria. I also say copy to, it knows the location, and then hit OK, and there's the filtered data from the original set. It's not roll-up, it's just picking specific criteria. Now, if I wanted to change the criteria, maybe say I only want records from the original, or rows from the original data that has quantity maybe greater than 3. And so I change this to greater than 3 and hit return. It wouldn't automatically change it because I just showed you a way to do it through the menu system. It's a manual interactive process. If I wanted to change for it to change automatically every time I make a change here, you do have to add some VBA code. So let me show you that VBA code that's already been added here. So here in the page 1 VBA code, if anything up here in the criteria range, which is what this first line of code essentially is doing, you would call a function called clear output. So it would clear where it's going to put the output, and then it would call this thing called advanced filter. Well, looking at those two functions, here's the advanced filter and here's the clear output. And I'll just focus a little bit here on the advanced filter, and it just eventually calls this method here, and see here we're not setting it to true, but then it just does what we asked. So with that in place, now I can change, look at the, pay attention to columns G to I. If I change this to greater than 4, you notice that the result set changed. Or if I change this to greater than 2000, so now we have more of an interactive way of allowing a user to change criteria and immediately seeing the result set over here. Well, while we're looking at VBA code that relates to the advanced filter, I want to go back to this page 2 and this point where we were using the advanced filter right here to come up with a distinct list. I want to show you how that works now. So if we go look at the VBA code behind that, when page 2, when J1 changes, when we do it by just clearing the cell, you can see here it calls a function called DistinctSort. Well, that's here, and it's just calling the advanced filter, and you can see here now it's using one of the input values into the advanced filter call is true. Well, I do want just the unique records coming out of the source records that I'm running the advanced filter on. After the advanced filter is called, then you notice here that a sorted is called, and that's just this function here, and it just sorts the data. So I get distinct values, and then I get it sorted. Let's go back over here to the page 1 and talk about the other preferred way of aggregating or rolling up summary data using pivot tables. Previously we talked about doing that using the SumProduct and then using this DistinctSort to get the distinct values, and then SumProduct to just sum things up. Now you notice here that we, just like with the advanced search, we're saying that the quantity has to be greater than 2 and sales has to be greater than 1,000. So using pivot tables, one approach would be to use the results here from the filtering we've done with the advanced filter, because the advanced filter has already reduced the original rows down to the rows that meet the criteria. So we could just pivot on that. But this method I'm going to show you relies on then the advanced filter being used. But we'll go ahead and through that real quick. We'll do an insert pivot table. Now that the data that I want to pivot on is not the original data, but the advanced filtered data that meets the criteria that I'm looking at. So then I come over here and just say salesperson in the rows. I want the quantity and rolled up, and I want the sales rolled up. So when you compare this to the previous approach, we've done it in a very quick way, but it relies on using the advanced filter to get the records that meet the criteria. Well, ideally we'd like to find a way that's more like the SumProduct method that doesn't rely on advanced filter. So let's try a different pivot table that works directly against the original data. So I'm going to insert a new pivot table, and this time I'm going to go back to the original data, and then have the rows be sales people. I'm going to have quantity roll up, sales roll up. Now you can see here when I do that, there's no criteria being met. It's just and therefore why it's different results than what you're seeing when we use SumProduct. So how do I get the criteria into this pivot table? Well, I can bring the quantity and filter and sales into filters, and then I can filter. Well, what's the quantity that we've got? It's got to be greater than 2. But then when we look over here and see what's available to filter, if I select multiple, it's got all the individual quantities throughout these different records. And if I'm dealing with thousands of records, I could have lots of different quantities. Well, the quantity, number of records here is few enough that I can kind of brute force it and just say that's got to be greater than 2. I'll remove these 2, and then when I go over here to sales, do multiple items, and anything greater than 1,000, so I can click all these out. But again, thousands of records. This would be impractical, but then I get the numbers that match this over here. Let's do another way, a little more tricky use of pivot tables that avoids this filtering issue that we just ran into. So I'm going to delete this pivot table, come back out here and insert another pivot table, go against the original data, put it in the same spot. Let's do salespeople rows, roll up quantity sales, but instead of putting filters, going to do something a little bit different. We're going to add quantity and sales into the rows. And now we end up with something that's a little messy, but now if we clean it up, first of all, what you want to do is go up here and select Design, Report Layout, Show Outline, and then come up here to Quantity, and you can specify value filters. And you can say greater than or equal to. Well, what is greater than or equal to? The quantity is greater than or equal to 2. And then you can come over here and say sales and a value filter greater than or equal to, you want to make sure you're talking about sales, greater than or equal to 1,000. And then to clean things up, you can come up here and collapse this so the columns values are hidden. You want to say collapse entire field, and then the same thing here, collapse entire field. So now you look at the totals, they're the same. And in this approach, you can specify ranges, and so it's a much more flexible way. You could even hide these two columns, and now you have pretty much the same looking result that you did with the use of SumProduct. So here's the two preferred ways of doing it. Either use SumProducts or this kind of tricky way of using pivot tables. The last topic of this video has to do with function tracing and timing. And because the video is running a little long, and the fact that we did talk about tracing of functions back in the cell references video, and we'll be talking about it more in the upcoming VBA videos. In the interest of time, I'm going to skip that for now and just focus on timing. So let's go off to spreadsheet here and just create a new worksheet. And let's say that you just need to get the a reference count of milliseconds. This is the number of milliseconds elapsed since the system was last restarted. And then you can choose to back up here and run it again, but I'm going to go ahead and run it again in this separate cell, and then you can compare the results. And you can see here that every time you run it, you're getting the number of milliseconds that's run off. And so it's a way to get some pretty granular timing in terms of maybe how long things are running. Another approach, you can try to use the now function, but as we discussed in other videos, that's a volatile function, so really don't want to do that. So use the Polaris provided function called update time, and that'll only update when you actually call the function. So here, that's the date times serial number, and that's in granularity of seconds. So when I call it again, it'll tell me how much time is run off in terms of seconds. So either use the GetTickCount for millisecond granularity, or use the update time for second granularity. Three other time-related functions provided by Polaris are the spin function, the wait loop function, and the timer loop function. So let's talk about each one of these individually. The spin function is dependent on whether you have a 64-bit or a 32-bit OS. And the main difference between the functions is whether a long, which is a 64-bit variable, is defined, or whether a 32-bit variable is defined. So as you spin, it's calling the GetTickCount, and then when it gets to the desired number of milliseconds, the function returns. The other function, now a different way to spin besides a tight loop like this, can also just use the VBA function sleep. If you're going to use the sleep function, you want to make sure you publicly declare it. But chose to implement it by default just in a tight loop. The wait loop waits in seconds, but could uncomment the code that uses tick count here and have it wait for a certain number of milliseconds. But we're already doing that with the spin, so I feel like the default way to do the wait loop is to do it in granularity of seconds. Now, as it spins, it actually yields to operating system events like somebody typing on the keyboard. Another way to implement this loop is you could do a VB call to application.wait. Now, if you do that, it does not incorporate do events. So the probably more flexible way to implement this is through the default way of just having a loop and then yielding by this code here. And then the last function is the timer loop. And the timer loop is used to carry out specific actions within a certain time frame. So it's literally a timer. Now this way this particular function's designed to work is you call it to start the timer, end the timer, and when the timer itself expires. So all functionality dealing with the timer is carried out by this one function. So each time it's called for one of these three reasons, the timer is turned off. Then it's looked to see if the timer is desired to stay on. And if it is, the beep indicates the timer has just gone off. And then the action you want to take each time the timer expires. And then this code here resets the timer based on a global or a cell value on the manage worksheet. Wanted to pass that in as a parameter, but just could not get that to work. And you can see here that the procedure that gets invoked every time the timer goes off is this TimerLoop function. Okay, it's been a long video, covered a lot of topics, but thanks for watching.